Welcome! If you're revising for your GCSE computer science exam, then you are in exactly the right place. We are about to break down a skill that is absolutely fundamental, converting between binary and denary. Think of it as the language of computers, representing all those on and off states with ones and zeros. Nailing this stuff is going to get you guaranteed marks.
Okay, let's dive right in by tackling a real question from a recent OCR exam paper. Honestly, there is no better way to prep than by working through the exact kind of problem you're going to face on exam day.
So this is it. Question 1A from the J277/01 Computer Systems paper. It's a classic conversion table, and it's worth 3. Count 'em. 3 crucial marks. Let's solve it together, step by step, so you can see exactly how it's done. Right? First up, we're taking this 8-bit binary number and turning it into its denary, or, its base 10 equivalent. This is a skill you absolutely have to nail.
The method is pretty much foolproof, and it all comes down to 3 simple steps. Step 1, write down the binary number. Step 2, pop the 8-bit place values right above it. And step 3, just add up the place values that have a 1 sitting underneath them. Let's see it in action.
So here you can see it all laid out nice and clear. We've got our place values, 128, 64, 32, and so on, all lined up. Now all we have to do is grab the ones that have a 1 underneath. So that's going to be 128 plus 64 plus 32 plus 16. And that gives us our first answer, 240. See, it's that straightforward. That's 1 mark in the bag. Okay, let's move on to the next row. This time, we're flipping it. We're going in the opposite direction, from denary to 8-bit binary. We need to figure out what the number 105 looks like in computer speak. For this, we're going to use what's called the subtraction method. I actually really like this one because it's kind of like a little puzzle. You start with your target number, in this case 105, and you just work your way from left to right, seeing which place values you can subtract from it. Okay, let's walk through it. Can we subtract 128 from 105? No, too big, so the first digit is a 0. How about 64? Yep, we can do that. That leaves us with 41, so our next digit is a 1. And we just keep this process going all the way down. Can we take 32 from 41? Yes. 16 from 9? No. 8 from 9? Yes. And you just keep going until you hit 0.
So the really important part now is just putting all those zeros and ones together in the right order. Our final 8-bit binary number is 011-01001. That's another mark earned. See how methodical it is?
For our last blank space, we're going back to a binary to denary conversion. This is great practice. Really helps lock in the method so you can do it super quick and accurately when you're under exam pressure.
So just like the first one, we line up our binary number with the place values. We hunt for the ones, and we add up the numbers sitting on top. In this case, that's 16 plus 8 plus 4 plus 2, which gives us our final answer for this question, 30. And with that, we have filled out the entire table. Boom. So we've done all the hard work. We've gone through it step by step. Now let's check our work and see the completed table exactly as it appears in the official OCR mark scheme. And there you have it. 240, 011, 0101, and 30. 3 questions, 3 correct answers. You see, if you just know the method and you show you're working nice and clearly, these are 3 easy marks just sitting there waiting for you.
So what's the big takeaway from all this? Let's do a quick recap of the key things you've got to remember when you're sitting in that exam hall. Right, these points are absolutely vital. Always use 8 bits if the question asks for it. You don't want to lose a mark for a silly mistake like that. Double check your addition and subtraction. It's so easy to make a small error under pressure. I always recommend writing your place values down first, just like we did. And practice makes perfect. Getting your head around number bases is a huge foundation for so many other topics on the paper. So there you go. You've just seen exactly how to tackle a common exam question and absolutely nail it. You've got the method down now, so keep that momentum going and ask yourself, okay, I've mastered this. What's next on my revision list? Maybe binary shifts or hexadecimal? Keep on cracking that code.